In this video, we will discuss how we can do the zigzag level order traversal of a binary tree. In zigzag level order traversal, in every level, we change the direction. In one level, we go from left to right, then in the next level, we change the direction and we go from right to left. So if we are given this tree and we have to find the level order traversal, so we start from A, we go to D, then we go to Z. So this is left to right, then we go from right to left in the next level. And in the next level we again go from left to right. So here we are going from left to right, here we are going from right to left, and here we are going from left to right. So this is zigzag level order traversal. So this is quite famous interview question which is usually asked in Amazon, Adobe, Microsoft. Let's see how we can solve this. So I will show you 4 methods by which we can solve this. First we'll use the recursion, then we'll solve it using the one queue and one stack. Then we'll see the third method which only uses 2 stacks. Then the last method that uses a double-ended queue. Let's start with the first method using recursion. So in the first method that uses recursion, first we keep a boolean variable LTR. So this means left to right. So we have initialized it with false. Then we have this for loop which runs from level 0 till height of the tree, and height of this tree is 3. Then for level 0 till height of the tree, we call this function print level. In this function print level, first we check if the node is null, then we return. If the level is 0, then we print the value of the node, and if the level is greater than 0, first we check LTR. If LTR is true, that means we have to go from left to right. So we call this function print level. First we call the left node and then we call the right node. If LTR is false, then the orientation is from right to left. So first we call the right node and then we call for the left node. And for each iteration in this for loop, we toggle LTR. So this means we change the direction. So this code is almost similar to the level order traversal that we have discussed in the previous video. Only the difference is introduction of this LTR flag. So just here we check the value for LTR. If LTR is true, we go from left to right. Otherwise, we go from right to left. I'm not going into the detail on how this code is working because that I've already explained in the level order traversal. I will link that video in the top right corner. You can have a look to understand how this recursion works. If we come to the time complexity of this method, then it is not very efficient because to reach each of the level, we are starting from the root node. So the worst case will be order of n square because the tree can be skewed, which means all the nodes are aligned in one direction. So the height of the tree in that case will be n. So to reach each of the level, we have to start from the root node and then reach that level. So the time complexity will turn out to be order of n square. So this is not very efficient. Now let's see the other methods which are more efficient. So when we discussed level order traversal, we discussed 2 approaches. The first one was by recursion and the second one was by using queue. So this zigzag level order traversal can also be done using queue with the help of an additional stack. Let's see how this works. So the first step is we need to create an empty queue and we push root node. Then we create an empty stack. We keep a variable LTR which we initialize with false. Then we have this while loop which we run till the queue is not empty. So in the first step, we find out the size of the queue. So queue has one element, so size of the queue is 1. Then we have another while loop which we run till size is greater than 0. So size is 1, we come in the while loop, then we decrement the size. So size is now 0. Then we have this current variable which we initialize with front of the queue, and front of the queue is A. Then we remove from queue, so the queue is now empty. Then we check if LTR is true, then we print. So LTR is false, we come in the else part, and we push the value of current in stack. So current is A, so we push A in the stack. Then we check left of A. So left of A is D, so we push D in the queue. And we check right of A, which is Z, so we push Z in the queue. Then we again come in the next iteration, we check while size. So size is now 0, so this while loop terminates. And then we check If LTR is false, so LTR is false now, we pop and print contents of stack. So let's say we are printing the output here. So the stack is now empty and the output will be A. And then we toggle the value of LTR. So LTR was false before, so it will be true now. Then we again come in this while loop. We check while Q is not empty. So Q has two elements, so size is 2. Then we run this while loop till size is greater than 0. We come inside it and we decrement the size. So size is now 1. Current is front of the Q, which is D. Then we remove from the Q, so we remove D. Then we check value of LTR. So LTR is true. So we print the value of current. We print D. And then we check left of D. So left of D is H. We push H in the Q. And we check right of D. Right of D is L. So we push L in the Q as well. Then we again come in this while loop. We check the value of size. So size is 1. We decrement the size. So size becomes 0. We initialize current with front of the Q. Front of the Q is Z. Then we remove from the Q. Then we check the value of LTR. So LTR is true. So we print the value of current. So current is Z. And then we check left of current. So left of Z is null. So we do not do anything. Then we check the right of Z. So right of Z is C. So we push C in the Q. Then we again check this while condition. So size is now 0. We come out of the while loop. So this if condition is false. And then we toggle the value of LTR. So LTR will now be false. Then we again come in the while condition. Q is not empty. So size of the Q is 3. We come in this while loop and we decrement the value of size. So size becomes 2. Current becomes equal to front of Q, which is H. Then we remove from the Q. Then we check the value of LTR. So LTR is false. So we push the value of current in the stack. So we push H. Then we check left and right of H. So both are null. So these two if conditions are false. Then we again check while size. So size is 2. We decrement the size. So size becomes 1. We initialize current with the front of Q, which is L. Then we remove from Q. We check the value of LTR. LTR is false. So we come in the else part and we push current in the stack. So we push L. And then we check left of L. So left of L is P. We push P in the Q. And then we check right of L. So right of L is null. So this if condition is false. Then in the next iteration, we again check size. So size is greater than 0. So we come inside. We decrement the value of size. So size becomes 0. Current becomes equal to front of Q, which is C. We remove from the Q. Then we check value of LTR. LTR is false. We come in the else part. We push value of current in the stack. So we push C in the stack. And then we check left of C. So left of C is null. And then we check right of C. So right of C is E. We push E in the Q. Then we again check while size. So size is now 0. So this while loop terminates. Then we come outside. We check if LTR is false. So LTR is false. So we pop and print contents of the stack. So first we pop C. Then we pop L. And then we pop H. So the stack becomes empty. And then we toggle LTR. So LTR will now be true. Then we again come here while Q is not empty. Size becomes equal to 2. Then we come in this while loop. We decrement the value of size. So size becomes 1. Current becomes equal to front of Q, which is P. We remove from the Q. Then we check value of LTR. LTR is true. So we print value of current, which is P. Then we check left and right of P. Both are null. So these two if conditions are false. Then we again come here while size. So size is greater than 0. We decrement the value of size. So size now is 0. Current becomes equal to front of Q, which is E. Then we remove from the Q. So Q becomes empty. If LTR is true, we print the value of current. So we print E, and then we check left and right of E. So both are null. So these two if conditions are false. Then we check this while size. So size is 0. So this while loop terminates. We come outside. We check the value of LTR. LTR is true. So this if condition is false. Then we toggle LTR. So LTR will become false. And then we check this condition while Q is not empty. So Q is empty now. So this while loop terminates. And this is our zigzag level order traversal that we have obtained using this method. So you can see here that one level will be maintained in queue and the one level will be maintained in stack. So this was stack and this was also stack, but these two were maintained in queue. And if we check the time complexity of this method, so time complexity will be order of n, and space complexity is order of n plus order of n, which is also order of n. So now let's see the third method, which uses two stacks. So in this method, we'll do the zigzag level order traversal using two stacks. So let's create two empty stacks, stack 1 and stack 2. We push root node to stack 1. Then we have this while loop which we run till both stack 1 and stack 2 are not empty. First we check while stack 1 is not empty. So stack 1 has element A. We come inside the while loop. Then we have this variable current in which we keep top of stack 1. So top of stack 1 is A. Then we pop from the stack. So stack 1 is now empty. Then we print the value of current. So let's say we are printing output here. We check right of current. So right of current is Z. We push right to stack 2. So we push Z here. We check left of A. Left of A is D. We push D also to stack 2. Then in the next iteration, we check if stack 1 is empty. So stack 1 is empty now. So this while loop terminates. We come in the next while loop, which we run till stack 2 is not empty. So current is now top of stack 2, which is D. We pop from stack 2. Then we print it. So we print D. Then we check left of D. So left of D is H. We push H in stack 1. And then we check right of D. So right of D is L. We push L to stack 1. Then we again check if stack 2 is empty. So stack 2 is not empty. Current becomes equal to top of stack 2, which is Z. We pop from stack 2. Then we print the value of current. So current is Z. We check left of Z. So left of Z is null. And then we check right of Z. So right of Z is C. We push C to stack 1. Then we again check if stack 2 is empty. So stack 2 is empty. So this while loop also terminates. Then we come here. If stack 1 is not empty or stack 2 is not empty. So stack 1 is not empty. We come in this while loop. We initialize current with top of stack 1. Top of stack 1 is C. We pop from stack 1. Then we print the value of current. So current is C. We check right of C. Right of C is E. So we push E to stack 2. Then we check left of C. Left of C is null. Then we again check if stack 1 is empty. So stack 1 has two elements. We set current to top of stack 1. Top of stack 1 is L. We pop from stack 1. We print the value of current. Then we check right of L. So right of L is null. Then we check left of L. Left of L is P. So we push P to stack 2. Then we again check if stack 1 is empty. We set current to top of stack 1, which is H. We pop from stack 1. So stack 1 is now empty. Then we print the value of current. So we print H. Then we check right and left of H. So both are null. So these two if conditions are false. In the next iteration, stack 1 is empty. So this while loop terminates. And then we come in this next while loop for stack 2. We set current to top of stack 2. So top of stack 2 is P. We pop from stack 2. Then we print the value of current. So current is P. Then we check left and right of P. So both are null. So these two if conditions are false. Then in the next iteration, current becomes equal to top of stack 2, which is E. We pop from stack 2. So stack 2 is empty now. We print the value of current. So we print E. And then we check left and right of E. So both left and right are null. So these two if conditions are false. Then this stack 2 is also empty. So this while loop terminates. Then we come in the outside while loop. Now both stack 1 and stack 2 are empty. So this while loop also terminates. So this is our zigzag level order traversal that we have obtained using this method. So here also you can see that one level was maintained in stack 1 and the next level was maintained in stack 2. So this one was stack 1, then it was stack 2, then stack 1 and again stack 2 at the last. So time complexity of this method is also order of n, and also the space complexity is order of n. Now let's see the last method in which we can use only one data structure and we can do this zigzag level order traversal. So in this fourth method, we'll use a double-ended queue. So double-ended queue is a data structure in which you can insert and delete both from the front and from the back. So first we create an empty deque and we push root. So we push A. Then we have this variable LTR which we initialize with false. Then we have this while loop which we run while this deque is not empty. So deque is not empty. We come inside the while loop. We check size of deque. So size of deque is 1. Then we have this inner while loop which we run till size becomes 0. We come inside it and we decrement the size. So size is now 0. And then we check value of LTR. LTR is false. We come in the else part and we keep a variable current which points to back of deque. So current will point to A. When there is only one element in the deque, front and back both will point to the same element. So here front and back both will point to A. Then we remove back from deque. So the deque is now empty. We print the value of current. So let's say we print output here. We check right of A is Z. So we push Z to the front of deque. And then we check left of A is D. We push D to the front of deque. In the next iteration, so size is now 0. So this while loop terminates. We come outside and we toggle the value of LTR. So LTR is now true. We again check here while deque is not empty. So size of deque is now 2. We come inside. We decrement size. The size becomes 1. We check value of LTR. LTR is true. Current becomes equal to front of deque, which is D. We remove front from deque. And then we print the value of current. So we print D. And we check left of D. So left of D is H. We push H to the back of deque. And then we check right of D. So right of D is L. We push L to the back of deque. We again come in this while loop. Size is greater than 0. Then we decrement the size. So size is now 0. We check if LTR is true. Then we set current to the front of deque, which is Z. We remove front from deque. So we remove Z and then we print the value of current, which is Z. We check left of Z. So left of Z is null. And then we check right of Z. Right of Z is C. So we push C to the back of deque. In the next iteration, so size is now 0. So this while loop terminates and we toggle the value of LTR. So LTR will be false. In the next iteration, size of deque is now 3. We come inside, we decrement the size. Size becomes 2. So LTR is false now. We come in the else part. We set current to the back of deque, which is C. We remove back from deque. We print the value of current. We check right of C. So right of C is E. So we push E to the front of deque. and then we check left of C, which is null. Then we again come here, while size is greater than 0, we decrement the value of size, we check the value of LTR, and we come in the else part. Current becomes equal to back of deque, which is L. We remove back from deque, we print the value of current, and we check right of L. Right of L is null, and then we check left of L, which is P, so we push P to the front of deque. In the next iteration, we decrement the value of size, so size becomes 0. We come in the else part, current becomes equal to back of deque, which is H. We remove back from deque, we print the value of current, and we check right and left of H. So both left and right of H is null, so these two if conditions are false. Then we again check the size, so size is now 0, this while loop terminates, and then we toggle LTR. So LTR is now true. In the next iteration, size of deque becomes 2. We come in this while loop, we decrement the value of size, so size becomes 1. We check if LTR is true, we come in the if condition, current becomes equal to front of deque, which is P. We remove front, we print the value of current, and then we check left and right of P. Both left and right are null, so these two if conditions are false. In the next iteration, we again check size, we decrement the value of size, so size becomes 0. We check if LTR is true, then current becomes equal to front of deque, which is E. We remove front of deque, so the deque is now empty. We print the value of current, so we print E, and then we check left and right of E. Both left and right of E are null, so these two if conditions are false. Then we again check while size, so size is now 0, this while loop terminates. Then we toggle the value of LTR, so LTR is false now. Then we again come in this while condition, we check if deque is empty. So deque is empty now, so this while loop terminates. And this is our zigzag level order traversal that we obtained using a deque. So here you can see that in the front we maintain one level and in the back we maintain another level. So time complexity of this method is also order of n. So once we've understood all these methods, let's see the implementation. So the purpose of sharing all these methods was to give you an idea how the same problem can be approached from different directions. So all the source code that I'll be showing, that is available in my GitHub repository. Link of that is available here and as well as in the description. Now let's see the implementation. So first we'll see the recursion approach. In the main method, I've created this tree. The root node is A, the left node is D. So in this manner, I've initialized all the nodes of the tree. Then I have this function zigzag level order traversal with recursion, and I am passing the root node. In this function, I have this variable LTR, which I have initialized with false. Then I have this for loop, which I run till level equal to 0 till height of the root node. And then I have this function print level, in which I pass the root, level, and LTR. After each invocation of this function, I toggle LTR. In this print level function, I check if level is 0, then I print it. If level is greater than 0, I check LTR. If it is true, that means first I have to go left and then right. If it is false, then first I go right and then left. So in this manner, I print all the nodes of this tree in zigzag manner. Then after this, we check this method in which we use the queue and stack. In this function, I've created a queue in which I push the root node. Then I create an empty stack and have this variable LTR, which I initialize with false. Then I run this while loop till queue is not empty. I check the size of the queue, and then I print all the nodes of this level by using this size variable. I check the front of the queue, then I pop it. If left to right is true, then I print it, otherwise I push it in the stack. And I push the left and right node in the queue. If LTR is false, I pop all the contents of the stack and then I print it. And for the next iteration, I toggle the value of LTR. And then we saw this method for two stacks. Here also I keep two stacks, st1 and st2. I push root in the stack 1. First I run this loop for stack 1, then I have this loop for stack 2. I check the top node of stack 1 and then I pop it and print it, and then I push the right and left to the stack 2. And then for stack 2, I pop the topmost node and print it, and then I push the left and right to the stack 1. And at the last, we saw this method using deque. In the deque method, I create a deque and I push the root node at the back. Then I have this while loop which I run till deque is not empty. I check the size of the deque. If size is greater than 0, I check if LTR is true. If it is true, then I pop from the front and I print it, and I push the left and right to the back of deque. Otherwise, I pop from the back and I push right and left to front of the deque. And for the next iteration, I toggle the value of LTR. So output of all the programs is ADZCLHPE. So that was all for this video. If you have any doubts or suggestions, please leave in the comment section below. If you like my content, please do like, share, and subscribe to my channel. It really motivates me to make more such content. And until next time, this is Sandeep Thapar signing off.